All right, we are live. Welcome to Livestream 255, Joshua Kemble Livestream. I'm Joshua Kemble. I've been an art director and art director for 8 years, illustrator and graphic design for over 20. When I'm not working on graphic design and illustration or art directing at my day job, I'm working on graphic novels like my 2 graphic novels that are currently out. 2 Stories, which is a comic graphic novel that's hand lettered, hand inked, and 120 something pages. And that is trying to destigmatize hard conversations about mental illness, particularly about my experience dealing with depression as well as caregiving for somebody with panic disorder. And then Jacob's Apartment, which is a slice of life coming of age story about 2 roommates kind of at their early adulthood trying to find their identity. And in their search for identity, both get kind of thrown for a loop due to life circumstances. Jacob, the main character, his father is diagnosed with cancer and he starts kind of questioning his faith and his belief system and kind of seeking identity and reason and purpose for existence. And then Sarah, his roommate, who is equally questioning her goals and choices in life because of a breakup that she recently went through, as well as a slew of one night stands that she's kind of going through to try to kind of make up for that loss. And so both are kind of at this confused point in their lives and find themselves drawn together. As they're drawn towards each other, they also wind up having their dreams and reality interweave in what's similar to if you took Eternal Sunshine for the Spotless Mind, mixed it in a blender with Ghost World, then you would probably have something like Jacob's Apartment. And you definitely, if you like that flavor, you'd like Jacob's Apartment. So check out those books. So on this live stream, I'm going to be working on a book called Not Death But Love, The Strange Supernatural Story of Elizabeth Barrett Browning. I will also say this might actually be the last stream done on this microphone. I got a much better mic because I have a birthday coming up, and so some relatives gave me a little bit of cash as like a present, and I kind of put that all together and then threw in a couple bucks myself and wound up getting a much better mic, which should be shipping pretty soon. So I'm really excited about that, and hopefully that'll up the quality of the audio and stuff for you guys. Anyhow, enough about mics. So I'm working on this book, Not Death But Love, The Strange Supernatural Story of Elizabeth Barrett Browning. It's about the historical figures Elizabeth Barrett Browning and Robert Browning, both very famous Victorian era poets, and kind of their journey in the supernatural realm, or not the supernatural realm, their journey kind of going to seances and getting Elizabeth getting really drawn into spiritualism and stuff like that. And so it's a really interesting, kind of intriguing story that is all drawn from the letters of Elizabeth Barrett Browning. And it's a story nobody's told yet. A lot of people have written stories about the Brownings because they had kind of this forbidden romance, which is really an intriguing story. And our story covers that, but it goes a little bit further and kind of gets into this untold realm of the Brownings, which I'm actually really excited about. So it kind of feels a little bit like if you took like Sense and Sensibility or like a Jane Austen novel and kind of mixed it with the ominous, mysterious feeling of Sherlock Holmes, like the Jeremy Brett version. It's got that kind of vibe to it, which is why I signed on to kind of illustrate it with Lavender Vroman, who wrote the script. And we're working on page 73. And my goal during the stream is going to be to color page 73 digitally and possibly learn a little bit more about neutrinos. So I've been doing a little bit of commentary as I'm working because it kind of just makes for interesting content, allows me to kind of digest new information. I think the left and right brain are really good to keep engaged together when you're working on art. And quite often when I work on art off stream, one of the things I do is listen to like audiobooks and stuff like that. So if I'm streaming and I'm kind of in the mood to like learn something, go down a rabbit hole, like in this case, I'm really fascinated by neutrinos. So I want to learn more about them. So I found a documentary called What Happened to All the Neutrinos on YouTube by the History of the Universe channel. So I have no idea. Who knows? This might be a weird propaganda video for some cult. Who knows? But we'll find out. But it does supposedly talk about neutrinos, and it's about 40 something minutes. So I was like, this might be fun to watch on stream and comment on and explain why I really love neutrinos. I think they're really fascinating. Okay, so all that being said, that's kind of the agenda. And I'd like to, at minimum, color at least 2 panels, but it'd be cool if I could color the entire page. I don't know if I'm going to be able to color the entire page because my hard cutoff's at 2, and I'm starting really late today at 11, but we'll see how we do. So anyhow, if you guys are tuning in, welcome, Night Gang. I appreciate you guys, and we're going to go to the art cam in just a second. Right before we go to the art cam, I would just ask one favor, which is if you are watching, hit that like button. That's much appreciated. Okay. I'm waiting, and hit the like. Got it. Okay. And you too, hit the like. All right. So anyhow, that's going to do it. Thank you for hitting the like button in advance or after the fact. And now we're going to go to our drawing camera. So right here over to my left, I think that's my left. It's always hard to tell because you're always pointing the opposite direction of the camera. But that is the page I'm working on. Down here is the kind of Wacom, my cheap Wacom camera. So you can kind of see a little bit of add a little visual interest to the whole drawing process. And then up here is my ugly mug. So you can see me while I'm talking. And this is the page we're working on. And for some reason, my Wacom is not plugged in. So good thing to check before starting your stream is to plug in your Wacom. Let's do that. And I know why I did that too, because there's something about the Wacom driver. When you start the computer, I'm on a Mac, and it's like whenever I start my computer, there's something about the driver that like won't allow my computer to load. So let's give it a second. Hopefully it'll register my Wacom. Let's just see. Yep, Wacom's working. That's good. Now let's get working on colors. So right here is the pencils, the finished pencils, which we finished on stream a couple days ago. And then here is the previous page with the shading layer turned off. So here's the shading layer. And these colors I have pulled up because we're going to pull a lot of these colors to use on the next page. I'm also wondering if we have, do we have Home? Home is the gentleman with the wild hair. I don't think we have his eye color on this page, so we might have to kind of go ahead and pull open page 71 as well. And here we go. This has Home's eye color. Good. So this is going to give us the color palette to work with, and we're just going to go through and go ahead and color the pages. And what I'll go ahead and do right now is I'm also going to throw on this What Happened to All the Neutrinos. And we'll kind of listen to this in a few seconds. So let me see if there's any order of business to kind of go over. Oh, Christopher Runciman's stream today was really hilarious. He went into a little bit of the backstory of my friend Jim Lujan, Corey Kerr, Scott Cirkland, and Gary Hodges. We have a boy band, a fake boy band that we've joked about on many an Artcasters episode called New Direction. And every song they wrote was like a double entendre that just sounds really pervy. But it's like, anyhow, it's gone as far as a joke to where we've mocked up like fake album covers with all of us as members of the boy band. And Christopher Runciman was kind of filling in some of the gaps and dishing some hot goss on our boy band. So I would encourage you guys to check out Christopher's stream from today. And then aside from that, I watched On Philip Chandler's channel, he had a really good interview with Jim Lujan that was really cool, and also a really good conversation with a friend of the show, Frank Salazar, who's also the show's moderator, my show's moderator. So you guys should check that out as well. And that's kind of shout outs, I guess. Yeah, and other than that, let's get into watching this content and then start basically flatting all the colors. So here we go. Let's learn something about neutrinos. And if you guys are up and drawing or working on projects, feel free to let me know in the chats what you're working on. It's always fun to hear what everybody's doing. And also, let me know what you think about me replacing this mic, because I feel like this mic's okay. It works okay, but it feels very compressed and loud. Like, I think this mic has a little bit too much gain. And so I'm really excited about being able to hopefully up the professionalism of that in the future. So, okay, here we go. We've got what happened to all the neutrinos. And let's check this out.
Do not see the real world. Your eye.
Okay, I'm already sold because it has a British narration. And how can you not like that? Like, how can anybody be against a British narration? Okay, let's start laying out our flats real quick. You won't believe this amazing documentary. It's about really cool things. Okay, let's continue.
Eyes are lying to you, or more precisely, your brain. In 2011, scientists at New York University ran a study which showed that we may perceive threatening objects to be closer than they really are. In January this year, researchers at the University of California found that in an effort to create a continuous image, our vision is stuck up to 15 seconds in the past, as do YouTube videos, so our brains need time to buffer. And finally, the sun is green. At a young age, we learn we mustn't ever look directly upon it. But those that dare, perhaps to witness the fleeting beauty of a sunrise, gaze upon a warm, yellow orb that gives life to most species on Earth. This color is not a trick of the eye, but a trick of the air. Molecules of nitrogen and oxygen scatter blue light away from us more, making the sun look redder than it truly is. But escape the bounds of the atmosphere, and to the human eye, the sun would appear that...
Okay, so it's interesting, and it's a good way to start if you're doing a documentary or a thing explaining neutrinos, to talk about things like the invisible things that we can't see that kind of blow the mind, because they don't necessarily match our literal comprehension of the universe. That's a good way to lead off when you're talking about neutrinos. They're kind of I don't know, I've heard them nicknamed like the God particle. They're like a really cool, a cool thing. So, and they're really hard for me to explain. So it's kind of fun to go through this and sort of like refresh on why I love neutrinos. Is it nerdy that I'm a geek about neutrinos? That's a good question. I guess if you're in chat, type 1 if yes, and type 2 if no. I don't think I have a very active chat though, because it is a night gang moment. It's like 11:12. So actually what's funny is my night gang usually doesn't show up like till much later or earlier in the morning of the next day. So we'll see if anyone comes. But okay, anyhow, let's continue.
The purest white, a combination of every wavelength of color it emits in different quantities. And this is the lie, the color white created in our minds. Objectively, the sun is, of all colors, green, emitting more green photons than any other wavelength.
Whoa, that's cool. I actually forgot about that. I didn't know it was green. That's pretty badass.
And that is not the only way our eyes deceive us in regards to our closest star. Ultraviolet rays that tan our skin, infrared that warms our faces when we step out on a sunny morning, radio waves which can be picked up by our technology, Our sun is constantly producing massive amounts of photons that stream around and through us at wavelengths our eyes simply did not evolve to perceive.
That is rad.
These limitations mean we bathe in a constant wash of particles that we simply cannot see. And this hidden world is not only made up.
Okay, so that's a really cool way of putting it. We bathe in a constant stream of particles we cannot see. How cool is that? I always find that really fascinating. Like, it's interesting, like if you look into color theory and stuff like that, and why like value shifts and like complementary colors are pleasing and stuff like that. But when you start actually getting into the optics of light and color, to me, it's always fascinating talking to somebody who's like heavily in science for like their job, because they are constantly refreshed on this kind of thing. But like for me, I forget the optics, like the basic stuff you learn in like elementary school, like why is the atmosphere appear blue, these kind of things. And just that, like, to me is why I like things like this, is just thinking, isn't it strange that the sun is green? That's insane. Okay, continue.
Of light. The sun also produces massive waves of particles that are so unresponsive as to have been completely undetected or even conceived of until the 20th century, and yet are so numerous that across the universe they outnumber the particles that make up ordinary matter 1 billion to 1. It is with these neutrinos we may be able to answer some of the deepest questions about our cosmos.
Okay.
The oldest light in the universe, the cosmic microwave background, is 380,000 years younger than the Big Bang itself. Before that, the universe was too hot and too dense for light to travel freely. But if the oldest images of the cosmos are still 380,000 years old, how can we ever know what happened before? What if we want to know?
So what's interesting about that is, and this always bugs me when people like kind of dispute a ton about like the age of the universe and stuff. It's like you literally can look, like a lot of people have talked about like time kind of not being apparent and stuff like that. And it's like you can literally look into the past by looking in the sky. There have been times, from what I understand, that like you can be looking at stars that no longer exist just because the light took that long to travel. And so it's, when they're talking about like the last observable moment of the universe, I think that's, I'm intuiting that I think that's what they're talking about, is like what we visibly can see in a telescope. Because we can, that's the funny thing. A lot of people talk about like time travel and does time travel exist? And to an extent, this is kind of a cool premise or idea, but it's like technically you're kind of time traveling when you look at the sky, which is sort of a cool way to look at life. I don't know. It's just interesting to me. Like the idea that like, dude, you're a time traveler. Like when, now I sound like some weird guy at like a Pink Floyd light show. That like, okay, the Griffith Observatory in Hollywood, anyone who grew up in the Los Angeles area went to this thing called the Pink Floyd laser show at the planetarium. And it was like this crazy laser show to like Pink Floyd. And they used to show it at Griffith Park Observatory in like this room, I think, called the planetarium, which is like this crazy room. But it was a really cool thing. I'm sure nowadays it would be way less impressive, because I think laser light shows are with like LED lights and the things they're able to do. Like, I don't know if you guys have ever looked up like drone footage, not drone footage, but like the thing they've been doing recently, like countries will have drones do like a choreographed light show. So they'll make like giant images in the sky, because they can program the drones like almost like pixels on a screen to cause light to appear in the sky in like specific patterns that make images and stuff. It's really cool. But that kind of outdates laser shows. But back in the day, that was like the old you know, go to a laser show and talk philosophy while listening to Pink Floyd and thinking about the expanding universe. That's how I feel right now. Okay, let's continue.
What the universe was like,
Hopefully you guys
not
are
just in
feeling
its
that
first
too.
year, but its first second. Our telescopes cannot tell us. They have reached an opaque barrier they cannot penetrate.
Isn't that
Yet
crazy?
astronomers have found a way to pull back the veil, to uncover these early moments in time, pushing back the clock to the most ancient map of the cosmos there is.
So, okay. So I wasn't wrong to intuit that. So that's observable time, which is insane that you can observe time that's that old. But that's through telescopes, right? Because like, again, like I wasn't kidding when I was saying like when you're looking in the sky, you're like time traveling for sure. It's kind of nuts, kind of crazy to think. All right, we are getting closer to this getting through. Okay, let's continue. Cool, cool documentary so far.
But to do that, they will first have to probe the secrets of these cosmic ghosts.
Cosmic
Secrets
ghosts,
that
yeah.
challenge our very understanding of how the universe works.
The entire history
This
of the
video
universe.
has been kindly sponsored by BetterHelp. Many
Nicely
scientists
done.
believe the universe is infinite, and that can get lonely sometimes. BetterHelp is an easy-to-use platform that helps you access therapy from your phone or computer. The last couple of years have been difficult for everyone.
So, I mean, I don't want to cut off their ad for BetterHelp because I definitely endorse that. But you know, what's weird is I think there can be a profound comfort in kind of looking at the vastness of the universe. It can kind of make you feel small and minuscule, but there's kind of a comfort in that sometimes because I feel like as human beings, that's one of the reasons I like learning about things like neutrinos and stuff. I feel like as human beings, especially like people who are neurodivergent and suffer from depression or just like are not neurotypical, I think a lot of the time you can get I mean, I think people who aren't who are neurotypical have this problem, but especially people who aren't, I think it can be really difficult to not to like avoid getting too far in your head and to an extent kind of scaling up your significance to where your problems become these insurmountable crazy barriers in life, you know. And there's something to be said for like looking to the universe or like the vastness of, you know, the solar system and stuff like that, just to get a sense of proportion, you know. Like I've heard interesting stuff where like astronauts who came back, who maybe were like really pro war before they went to space, um, like when they were on like a spaceship or at like the International Space Station and they're looking down at the Earth and seeing that it's just this circular globe that's just spiraling around, and like all the countries are these little dots, you know, like these little swatches. And you know, I've heard astronauts talk about like coming back and being very anti-war. Like the people who went in and were very pro-war became very anti-war because they just saw the reality of like the small little planet, the little rock we all live on, and kind of the insignificance of our little disagreements between our little spots on the speck in the universe we occupy. And I think that's like, again, I think with the right perspective, it can be a really good thing to kind of observe the universe and observe the vastness of space and kind of realize our smallness in comparison to that. You know, it's interesting, but let's continue with their BetterHelp ad.
And it's so important to not only stay physically healthy, but mentally too. One of the barriers for me had always been that in times of crisis, I didn't know how to find someone to talk to. so it felt easier just to ignore it. BetterHelp are a great solution to this problem with over 20,000 therapists with a broad range of expertise, just a click away.
Good advice.
All you
though.
need to
People
do is
should seek
access their
therapy.
platform, fill out the
Not
questionnaire with your
necessarily on
specific
BetterHelp,
needs,
but
and
just in
BetterHelp will
general.
match you with a licensed therapist to listen and help you. It's convenient, straightforward, and trusted by more than 2 million people who have signed up and tried it. So head over to BetterHelp, that's betterhelp.com/HOTU for 10% off your first month.
Okay.
Thanks again to BetterHelp
I gotta
for
give
supporting
props to
education
England.
on YouTube.
Saying H instead of H is pretty rad.
Why would you build a telescope inside an aeroplane? It is the morning of December the 1st, 2010. At the end of its 10-hour flight, a retrofitted Boeing 747 returns to an Air Force runway in Palmdale, California.
Oh, wait.
One change is
pause
instantly
there.
noticeable.
Wait. Where did they say? Palmdale? Part of the Antelope Valley? Oh, snap. That's right. I live in I live right real close to NASA and Edwards Air Force Base. Good point. Thomas Adams said pale blue dot. Exactly. But so this is another reason these documentaries are really interesting. I had no idea that we had a retrofitted 747 with a telescope flying literally probably right over my house. Probably quite common, quite often. You see some really strange planes around here, but that's exciting. Makes me feel a little more relevant living out in this weird desert town. Take that, people who don't live in the Antelope Valley.
Peering out a retractable door at the rear of the plane rests the 20-ton, 2.7-meter-wide mirror of the Sophia infrared telescope.
Oh, that's cool too. That's
when
a
the
good
weather
name.
warms, it flies south for a second winter. From Palmdale to Christchurch, New Zealand, the annual migration allows access to an entirely different part of the sky.
That's right.
During its observation
From
periods, as many
Palmdale.
as 100 flights a year, Sophia flies at an altitude of 12 or so kilometers, not all that higher than most commercial flights. And in doing so, it captures a light that the air beneath it would block.
Oh, interesting.
Water. It not only forms clouds which block visible lines of sight, while it looks clear to us in small quantities, entire oceans reveal its true nature.
Oh,
it appears
cool.
blue because it absorbs red light, and it also absorbs invisible infrared light. Infrared light that holds the universe's most distant secrets.
Ooh.
As the universe expands, light stretches, and after enough time, much of it arrives to the infrared. When Sophia flies...
So let's pause and just absorb this for a second. So the ocean is absorbing a ton of infrared light, and so I guess to map the infrared light, they're doing this flight to observe the ocean in its full totality. That's what it sounds like, because it sounds like why they're doing that flight path is to get a really big view of the ocean so they can kind of measure stuff. That's interesting, and I'm not sure the specifics of how they're doing that. I'm sure they're going to get into it, but how cool is that? Also, the reminder, I always forget this too, that infrared light is it sounds like that's light decay or something. It's as the light travels away. This is my bad understanding of science. Thomas, am I getting this wrong? If so, correct me. All right, let's continue.
99% of the planet's water is beneath it. The telescope can catch wavelengths of light that would never make it to other equipment on the ground. Wavelengths that denote the births and deaths of stars, the formations of planets, and even dust surrounding supermassive black holes at the hearts of galaxies.
Okay, sorry. I'm going to pause here and just think, how badass is that the ocean can tell, just by observing the ocean, you can find a map of black holes in the universe. Dude, okay, this is why, again, I've never been able to fully understand physics because it's heavy, It's very hard to understand. there's guys who are really good at like breaking it down to like more simple explanations and stuff. But like to me, I also kind of enjoy that about it. Like it's kind of like the similar thing to staring at the vastness of the universe, and as Thomas was saying, you know, realizing we're on this little blue dot can be like comforting. There's also a point where I really enjoy being a little out of my depth. Like I like hearing knowledge that's ascertained that I have trouble kind of inferring or understanding. I just think that's so fascinating. Thomas Adams said the light shifts red because of the Doppler effect. That's right. That's right. That's why it's good to watch these things.
For more than a century, humanity has had to use technology to overcome the limits of our perception. Telescopes can reveal to us the massive made insignificant through distance. Microscopes magnify what is under our very noses. The smaller the object of study, the smaller a wavelength of light you need in order to study it in detail. Today, electron microscopes can achieve resolutions 4,000 times smaller than any optical microscope.
That's cool.
But how do you study or even detect the smallest known particle in the universe? A particle so small, we don't actually know how small it is.
We're getting into the fun neutrino stuff. Isn't that great? There's a particle so small they can't tell how small. Oh man. Okay, they're gonna get into this, but neutrinos are so cool because I'm going to give a few spoilers. I have not watched this particular documentary, but I'm going to talk out of my butt about the few things that I find fascinating. I'll talk about a few of the things. I don't want to give away everything. But one of the things that's really cool about neutrinos is it's one of those particles they know exists, and yet like they've never, at least from my understanding, I don't think they've ever been able to catch it. I think they've caught like a version of a neutrino in a specific form. From what I recall, I think that's happened once, but it's like it's close to impossible to find, and yet it has to exist according to the mathematical equations of the universe, which is really interesting. So it's like scientists know this thing's out there. They know it by its effects, and I'm sure it's going to get into like how it was kind of proven that these things must exist, but it's like it's like this nightmare trying to kind of capture or catch or study neutrinos, but they know they're like this fundamental thing that's like, you know, as they were saying, it's like it could contain the history of the beginnings of the universe. So how fun is that? But it's also fun to get into that, you know, that realm where it's like, dude, you know, there are things out there that are so small, they don't even know how small, but they know they have to be there. It's so great. Anyhow, let's continue. Also, this is really well filmed.
In late 1951, Frederick Rains and Clyde L. Cowan Jr. began Project Poltergeist, the first experiment in neutrino physics. Okay. 2 decades prior,
let's pause this. Did that predate the movie Poltergeist? Because it looked like it was like a black and white photo. So I'm thinking this predates the movie Poltergeist. That's really interesting. Is that where the name for... See, now this is one of the hardest things about doing art while going down a rabbit hole on YouTube. It's like I want to look up the etymology of the word poltergeist. I'm sure it probably predates that. It must mean ghost or something. And it must have predated the project. But anyhow, let's continue.
Physicist and mathematician Wolfgang Pauli had proposed the concept of the neutrino. He sought to balance an equation governing the process of nuclear decay. In some unstable nuclei, a neutron will spontaneously transform into a proton and an electron. The exact amount of energy was based on the principle of balance. Add up all the energy in the particles at the start of a reaction, and it should equal the total energy of all the particles present at the end of it. But the electrons experiments were catching all came up wanting.
Isn't that
Either
crazy?
the law of energy conservation was wrong at this level of subatomic particles, or another source of energy was missing. Perhaps, as Wolfgang Pauli first proposed, there was an even smaller particle which the neutron had broken up into, a particle neutral in charge which escaped the nucleus, but also escaped.
Ooh, okay. That's interesting. You know what's funny? I don't know if I knew that before, but I'm thinking neutral and neutrino. Anyhow, let's continue.
Capture. Direct detection of these neutrinos was deemed essentially impossible. They were simply too small and too ghostly. 100 trillion of them stream through your body every single second as if you were simply not there. In fact, Pauli once said of the neutrino, "I have done a terrible thing. I have postulated a particle that cannot be detected." But it was the nuclear revolution of the 1940s that eventually proved him wrong. A child of Russian immigrants, Frederick Rains was born in a small New Jersey town in 1918. As a boy, he developed a love of music, singing in particular.
This is interesting too. So now I'm kind of curious how that worked out, because I'm guessing the energy. Okay. Oh, pull turn to knock and Geist is ghosty. Oh, interesting. Nice. Thomas said I cheated, and it's German for ghost. Nice. He said I cheated and went to Wikipedia. Well, how fun is this though? Because like technically the comic I'm working on has some ghostly things occurring in it, especially later on. So it's kind of fun that it's not only are we learning about neutrinos, but we're learning about knocking for ghosts. Ooh. I should like do a break in the stream and just walk around with a handheld camera acting like I'm freaked out and hunting ghosts in my house. Have you guys ever gone down a ghost YouTube rabbit hole before? I definitely had like a month or two where I'd watch those ghost hunters things. Not because I believed them, but just because it was entertaining how worked up people could make themselves, like in a dark room, like and especially when they're in groups of other people, where like there's a really obvious just I don't know noise of like a cricket or something, and they're like, "Did you hear that? Did you hear that?" And then like they change the color of the video to like night vision green. It's like, oh my gosh, it's a ghost. Let's get out our little electrometer or whatever it is that they're like reading. Anyhow, let's continue.
But his love of science grew from a moment of boredom in school where he looked out a window and noticed the splitting of light, known as diffraction. Rain's passion eventually led to a PhD in theoretical nuclear physics, and he joined the Manhattan Project in 19...
Okay, we have to pause here and enjoy the fact that he said PhD. Really, really wish I were British. That's just a really cool way to say H. H.
1944. Over the years, he rose up
Also,
the ranks to
Manhattan
eventually
Project's
head
pretty
nuclear
amazing.
weapons testing in the Pacific.
Create an amazing website with Fiverr. You'll need
Sorry,
your web
guys.
developer, UX
I like
writer,
to give them
and
their
Amy,
ad
a
revenue.
Fiverr
So
freelance
I will
graphic
watch
designer with dozens of 5-star reviews who will join your team from her favorite coffee shop. Don't forget to
at least till I can technically skip it.
It was during a
I don't wanna do
sabbatical
ad
that he
block for
realized the nuclear
creators.
fission reactions provided by the deadliest bomb known to humanity could provide the concentration of neutrinos needed to detect one of them.
Ooh.
Still, he likened it to listening for a gnat's whisper in a hurricane. As the 1950s dawned, Project Poltergeist...
Sorry, okay. I want to pause here and just appreciate listening for a gnat's whisper in a hurricane. Interesting. Okay, let's continue.
planned to capture the elusive particle for the very first time by detonating a 20-kiloton nuclear payload, which could provide a surge of neutrinos in sufficient quantity that maybe a mere handful actually had a chance of being picked up by a detector placed a mere 50 meters away from the explosion.
Bad placement there.
This detector was filled with a special mix of liquids that would flash in rare circumstance, the creation of a charged particle after a neutrino collision. 1,000 times larger than previous detectors. They named it El Monstro.
El Monstro. Ooh.
Thankfully, Rains and his...
Okay, how cool is this? Like, here's the thing. We were talking about this on Artcasters, and I was talking about this on a video, but I think we got a little more in depth with it, with improvisation and kind of inspiration for artists. And like, how cool is that? Like, to me, I mean, hearing like this nickname for this particle detector that they made during the Manhattan Project, like all of this stuff could be mined for like stories, you know, like you could make like so much cool fiction from this, or science fiction from it, or even historical fiction from it. It's just like, I think people who get writer's block, and this is no diss on them, because as a young artist, I did get like writer's block when I was really new to this whole thing. But as I started writing more and more, and also just kind of exploring more things and learning more things, it's like you can't really run out of things to write about. There's things everywhere. I mean, just open up, you like watch a YouTube video about neutrinos and you'll get like charged. No pun intended there. It sounds like they're trying to get the neutrino to charge a particle, but my point is, I think charge an electron was what they were saying. But anyhow, so my point is that this stuff is super inspiring. Like, I could come up with a wacky, crazy science fiction story just from this. Like right now, if I weren't coloring my comic, I could like pull open a Word doc and start typing away crazy Manhattan Project inspired thing. Thomas said, I always find it amazing that the old physicists and scientists are so well read, especially compared to today. Yeah, and the other thing that's fascinating to me in general, just about this era and time, and then also, like, I don't want to be one of those people who has like what they call scientism. You know, I don't think scientists have all the answers. I think often people will always err in assuming that scientists can answer philosophy, which is just a different kind of realm than like biological or natural sciences. And so it's like, I'm definitely by no means like a person who has scientism. However, people who like totally, deny the importance or the power of science, and especially mathematical physics, it's like they're just ignoring entirely the fact that like mathematical equations proved the possibility of an atomic bomb. And they tested this theory, and it led to the most horrendous, powerful weapon known to man. So again, like if their equations were off, it just wouldn't make sense that like what they're doing would have led to exactly, in fact, a much more incredible result than they even calculated. It's just a testament to like the brilliance of these people that like with just math, just math, being able to create, the most powerful thing known to man that man's ever made. It's mind-boggling to me. And again, very humbling, because it's like, yeah, I'm making a comic. I'm not making an equation that can create something that could literally destroy our world, which is a frightening thing, but it's also, you got to admit, that requires like a brain, and an extraordinary amount of intelligence to just have figured out. Okay, let's continue.
His colleagues realized that if they added cadmium salts to their liquid, they could make it even more sensitive. A bomb would no longer be necessary. A nuclear reactor one could turn on, leave running, and turn off became the more sensible option.
That's
and
a
in June
little
of
more
1956, Raines sent a communique to Pauly. A neutrino collision had been detected. Neutrinos were no longer theory, a mathematical concept used to balance the equations of the universe's inner workings. They were real, if barely tangible.
Okay, so that's rad. So that's how they they detected a neutrino. It's also interesting that their first version of it was going to be like, hey, let's just blow up an atomic bomb and just kind of see what happens. That is one of the most frightening things about that era of time, is just that people were scientists were so gung-ho about just like, I don't know, let's like test it by like blowing up a giant thing that like we have no idea the absolute destruction and power that we're creating. Thomas said math led to the discovery of Neptune. The orbit of Uranus was not right according to the math, so they looked to where the equation said a planet would be, and bam, they found it. Yep. Hell yeah. And again, like, it's like science isn't perfect. It's not like this system that is flawless. It's just, I think the thing that's cool about it is the self-correction of it, and the fact of like, if an equation doesn't work, there has to be a reason, right? That's how they, that I from what I understand, I think that's how they found mRNA as well, because they were kind of testing and they were like, okay, for certain theories to be true, DNA would have to have a way to basically like send it, like replicate itself. And so it's like they looked for it, and I think that's how they found messenger RNA. Just based on a theory where it's like, well, this thing has to exist that would like replicate like messages from like DNA, like DNA codes and strands and stuff, because otherwise, like, I think it was the theory of evolution or something, but it's like that would have fallen flat if they found that there was not such a thing as messenger RNA. But they look, and there it is. It's a process, not a destination. A lot of people forget that. Yeah, I think so. I think a good proof of it is like people expecting scientists doing science in real time to be consistent with their message, where it's like, no. Science is super inconsistent in the moment, like, because you're learning new things and correcting your information as you go. It's why, like, I have a friend who's an engineer. I was talking about this the other day about my need to like be a little more confident and certain with the way I communicate to people. And I think I brought up my friend who's an engineer, but I'll bring it up here too. Same story, where basically I have a buddy who's an engineer, and he talked about having trouble having conversations with kind of like what he would consider kind of like normies, like people who don't do science or comprehend or even understand, like, especially engineering, because he'd say something, they'd be like, is that true? And he's like, well, it's like 99.8% certain. And they'd be like, oh, so it's not really like it's not 100% true. And he's like, no, like as an engineer, it's like that's as true, like that's as true as you can get. Like you never get 100, you get 98, you get 99%. Like that's a very confident truth. And he was talking about that being very frustrating, having to like kind of dress it up and be like, yes, 100%, even though it's not technically, like, no scientist worth their salt is going to say 100% anything, because again, it's like a thing in process, and it's constantly being revised and corrected, and people get rewarded for like poking holes in it and proving things wrong. So anyhow, let's continue. This is really fascinating though. I love deep diving into stuff like neutrinos. It's one of my favorite things. Okay, let's continue.
Nearly 4 decades later, Raines was awarded the Nobel Prize for his work.
That's right.
Nowadays, modern detectors make their neutrinos a little differently. The Microboon experiment at Fermilab and upcoming Dune project employ liquid argon as a detector, and Fermilab creates neutrinos using a particle accelerator.
Okay.
But not all.
So I wanted to also bring this up. Like, one of the things I love about neutrinos too is it's a huge reason for like particle accelerators, for like the Hadron Collider. It was a big part of what they wanted to test with the Hadron Collider. It's really interesting like the more you dive into this like neutrino stuff, it's just super fascinating, like how big of a deal it is for scientists to like try to find this thing, and be able to like kind of study it. Okay, let's continue. Enough to where they're building giant colliders under the earth to like with like these massive tunnels to be able to create an impact that's like so strong that it can like cause like, anyhow, let's continue. It's just really cool. Isn't this cool? I mean, like, dude, if this isn't inspiring for an artist, I don't know what is. Like, anyhow, let's get. They're going to talk about these testing sites, but my point is, like, doesn't that make you want to write science fiction? It's amazing.
All detectors need to make their own neutrinos. Some are on the hunt for those crafted by nature itself. The Ice Cube Array in Antarctica
this thing's
features
cool.
86 cables
giant balloon.
drilled into the ice, encompassing a
there's a
total
giant balloon.
volume of 1 cubic kilometer, equivalent to 1 million swimming pools.
Oh, cool.
Since opening in 2011, Ice Cube has hunted for the rare neutrino, which has traversed billions of light years. For any and all of these projects, the important factor is shielding. Neutrino detectors are hidden in mines, underneath hundreds if not thousands of meters of rock, or, in Ice Cube's case, solid ice. This prevents other small particles raining down on Earth from causing interference, cosmic noise that would otherwise drown out the minuscule signal a handful of neutrinos every so often deign to give.
Isn't that crazy?
But the question remains, just why are neutrinos so incredibly hard to detect? And why does that make them ideal for detecting the earliest moments of the cosmos?
Okay, this is going to be fascinating. Let's pause for a second. We're at pretty much the hour mark. So we're probably going to play a trailer for my graphic novel that's out. I hope you guys are enjoying this. Let me know in the comments too if this is fascinating to you. I just like love stuff like this. It's one of my favorite things. It's so funny. Some people like partying and like going out with friends and stuff like that, and that's really fun for me. But one of my favorite things on the planet is to be like at home working on a comic and like listening to weird stuff about science. It's like it just I don't know, there's something about that that's like it's just an amazingly fun thing. You know why I think I like it is it engages the imagination and the critical mind, and it's like both of which are really important for artists. You know, I think you need a critical mind and you need a vast imagination to do what we're doing, unless you're flat coloring, and then you just need impeccably high levels of patience for boring activities. Most artists I know just absolutely hate flat coloring. I'm mixed about it. Like, it can be kind of fun because you just get in the zone, and like, to me, but it's not quite as like engaging and fun as like the rendering process, which is a lot more fun than the flatting process. And it's not quite even close to as meditative and kind of spiritual as like traditionally inking or something. But it is one of those processes in the comic making process or illustration process that can be kind of cool, because it's almost like it's like a production work kind of thing where you're just kind of you get in this zone where you're knocking out very repetitive tasks, and that can be really fun when you're comprehending the neutrino itself. So anyhow, to me, it's really interesting. It's about as interesting as it can get. Did I mess up on the previous page? I think I did. Ooh, look at that. Glad. This is why sometimes you get double blessed in this process. I screwed up my color fill here. I also just realized the process of filling color, right, is like, I mean, in comic colorists just call it color filling, right? or flatting. But I wonder when Philip Chandler is coloring, does he nickname himself? He's like, "Hey, my name's Color Phil." That's the worst joke ever. Philip, if you're listening, I hope you enjoyed that terrible joke. All right, let's I'm here all night, guys. I'm gonna just finish up the floor here, and then we're gonna play a trailer for Jacob's Apartment, methinks. And I'm gonna step up, get some water whilst the trailer is playing. Hopefully you guys can take that opportunity to, if you haven't yet, click that like button. And then we'll come back and we'll finish up this listening to this neutrino thing. And my goal tonight is to finish at least 2 panels, and I think I'm well on the way to do that. So here is the trailer for Jacob's Apartment. We'll be right back, and then we'll check out this Gnat's Whisper, which, by the way, that's great. Even that name's great material for like a book or a story. Okay, let's see here. Here we go. Here is the trailer for Jacob's Apartment. I appreciate you guys hanging out and watching the stream, and I'll be right back. Speak clearly, it seems that only in dreams can we be these things we've seen. Walk around breathing I don't know the part to play in this heart of mine. There's dissonant things, they split at the seams. By the way, there's a little thing I like to do in books that's scientifically impossible, and that's a hint. It's in Jacob's Apartment in the sky. So if you guys have bought Jacob's Apartment and you catch what that is, just let me know. But it's a scientifically impossible phenomenon happening in the sky in a lot of my comics, because I just like the look of it. Okay. I know Dee Dee Willingham listens to my podcast or stream quite often, and this is a shout out to her. I'm going to give you a moment of ASMR as I open up a mango cart to get me through the last hour of this stream, and hopefully flat coloring the last panel. So here's your ASMR for the night. Right? Anyhow, that was it. It is kind of a nice sound. Like it'll be a lot nicer when I get my new mic to hear sounds like that, and honestly to get to hear my voice not all compressed and ridiculous. But hopefully you guys will enjoy it. You'll have to let me know. Really right now, just take a mental snapshot of the way the audio sounds today, because like tomorrow if I stream, which I think I'm going to do, that might be different. So all right, let's get into it. Let's start watching part 2. We're checking out. So we're working on Not Death But Love, if you're just tuning in, the strange supernatural story of Elizabeth Barrett Browning, which is a historical fiction graphic novel that I'm illustrating for Turner Publishing, written by Lavender Vroman. And we're learning about neutrinos, and we're on part 2 of what happened to all the neutrinos on the History of the Universe channel on YouTube, and we're doing commentary of said video, whilst also doing flat color. So let's do it.
In your entire lifetime, the likelihood of you interacting with Neutrino is about 25%. Not bad odds, you may think. And yet, 100 billion pass through your thumbnail every second. About 100.
Okay, sorry, let's pause there. That's one of the things that got me super fascinated about neutrinos, was the idea that there is this thing that is literally passing through, like, I think he said 100 trillion every second or something, through your thumbnail. I mean, dude, how is that not interesting, you guys? Like, there's this thing just moving through all of us. It almost sounds like, the Force or something like that. You guys, it's like the neutrino makes metachlorians a little cooler, even though that's one of my least favorite parts of Star Wars, was when they start sciencing something we already believed. Which, by the way, pro tip, if you guys are writing a story and you already gained the suspension of disbelief from people, there's no need to over explain it. Like, just as a tip. But neutrinos, let's over explain the hell out of it, because it's fascinating.
180 million billion neutrinos produced only by our sun pass through the Earth every minute. A light year of lead would only stop half the neutrinos passing through it. Generally, neutrinos simply do not interact with other particles, be they matter
another fascinating,
or be they light. The four fundamental forces of gravity, electromagnetism, and the strong and weak nuclear forces govern how particles interact with one another. Gravity draws everything with mass together, like tiny beads rolling along depressions of space-time created by the presence of others. The greater the mass, the deeper the depression, the greater the appearance of gravitational pull. For a long while, neutrinos were thought to have no mass whatsoever, just like photons. While they could fall along the curves in space-time, they left no tracks of their own for other, similarly small particles to notice. Yet photons are the messengers of the electromagnetic force. Anything with electric charge, in our day-to-day, anything that's made of protons and electrons, interacts with the electromagnetic force to some degree. But neutrinos are the ultimate neutral particle. They are not composed of smaller pieces and are neither influenced by electric nor magnetic fields. Tiny neutrinos simply slip through the gaps. Of course, the mysterious substance called dark matter is invisible to the electromagnetic force, but at the very least we can see its gravitational influence. The strongest of the forces is the strong nuclear force, which has the job of binding together fundamental particles.
Okay, so let's pause here. Let's say you were trying to make like a story about a bunch of fighters, and you're trying to give them like powers. You want it to be kind of similar to like Avatar: The Last Airbender, where it's like they have these different fighting skills. One is like earth, one is fire, one is wind, and so on, right? Well, that's kind of played out. Well, what if you used like electromagnetism and like, all these different invisible forces? Like, what if that was what you used for like the secret powers of these like kung fu masters or whatever? I'm just throwing this out there just to say this is why this kind of stuff is so fun for a creative to kind of listen to. It's like you can glean so much for storytelling. And I'm like a slice of life guy, but I've even done a very short comic. I don't know if it's on my website, about neutrinos, just because I like them so much. It was like a one-pager, but that's how much I love neutrinos. I want you guys to love them that much too. Okay, let's continue.
Called quarks, and as a byproduct holds together neutrons and protons that make up the nucleus of an atom. Neutrinos, however, are not quarks, and so the strong force, too, is happily ignored.
Isn't that crazy?
The only fundamental force that neutrinos appear to be ruled by is the weak nuclear force. Indeed, this was the very reason Pauli predicted their existence, as the weak force needed to create them to maintain a balance of energy. In this way, neutrinos are ghosts, barely skirting the laws that govern our reality.
Isn't that rad?
They exist to explain why the energies of certain particles and certain reactions that we really can measure look the way they do. But that does not mean that they are exclusively cosmic duct tape injected into physics merely to make our equations look nice. We can use them as probes, studying some of the most extreme events in the universe.
Dude.
On February the 23rd, 1987, a 168,000-year-old explosion struck the Earth. An international effort hunted down the culprit. In the Large Magellanic Cloud, a dwarf satellite galaxy of the Milky Way, the nuclear furnace of a massive star had failed.
Isn't that cool?
A gravitational
it's
implosion
frightening.
concentrated enough of the star's mass for one last death whale.
Oh,
A supernova. But
Isn't that
hours
cool?
before the light of this cosmic explosion had reached our telescopes, a detector inside a zinc mine collected the signatures of 11 neutrinos. Born in 1926, Masatoshi Koshiba had originally planned on studying German literature, but after receiving a failing grade in physics, he overheard his teacher speaking ill of his abilities. Spite, it turned out, was a powerful motivator.
okay, let's pause here.
A month later,
Okay, so spite drove a guy to become one of the best physicists. Yes, it's not just artists. I've talked about that multiple times, that spite can be an unhealthy driver for the long term, but you'd be surprised how far spite can take you. Like, I definitely had quite a lot of moments in my life where I was very spite driven, where I had people who doubted me. I still have this occasionally. Sometimes if somebody doubts me, the spite of just proving them wrong can be a really good motivator. Not as much as I've gotten older, but I still get it here and there. It's not the most sustainable of the inspiration forces out there, but I won't rule it out as like that can be a big motivator. Okay, let's continue. I just think it's cool that this dude was like, "Oh yeah, teacher."
he'd raised his grade enough to pass the requirements for the physics department. When he eventually attended New York's University of Rochester for his PhD, he completed the program in less than 2 years.
Hell yeah.
Fast forward to the 1970s, and Koshiba sought to rewrite the laws of physics.
Dude, go Koshiba. Good
He
job.
wanted to observe the decay of protons. He'd hoped to prove the grand unified theory, which sought to unite the two models with which physicists describe the universe: general relativity and quantum mechanics. And this is what his Kamioka nucleon decay experiment, or Kamioka NDE, was meant to do. A cylindrical tank holding 4,500 tons of water, hidden a kilometer underground. But ultimately, protons proved far too stable. If they ever do break down, it happens so rarely that Koshiba's machine would never be sensitive enough to catch one in the act. However, he did realize that, with a retrofit, it could be sensitive enough to catch neutrinos streaming through the planet. The arrangement of 1,000 photodetectors would also indicate from what direction they were coming. And just 2 months after his experiment began collecting data, Koshiba's team hit the proverbial jackpot. It was actually 2 days after supernova 1987A's light had reached Earth. Researchers at the University of Pennsylvania had sent a fax to their colleagues in Tokyo informing them of the explosion. And it was here they found what they'd been waiting for. For 13 seconds, Kamioka NDE had captured a burst of neutrinos streaming through the Earth.
Isn't that crazy?
The timing had been perfect. Only a few minutes prior, the detector was shut down for a full 2 minutes. And so, Kamioka NDE helped open up a new era of astronomy, which hoped to unveil natural phenomenon too opaque for light to penetrate. And over the last decade, neutrino detectors have been joined by gravitational wave detectors that have helped astronomers explore the mergers of black holes and neutron stars.
Also, just like, like, especially for comic people, it's like, if you read like a lot of the old, Marvel comics and stuff, a lot of them are like artists just kind of doing junk science based on real science. Like, just getting really inspired by like, okay, let's take a look at this like weird photo detector machine. It looks cool. Can I build something like that for my story? Doctor Strange is like really inspired by like the wackiness of physics and just having fun with it rather than actually, holding to it. But it's like, these things again like can be real inspirations for people. Okay, let's continue.
In 2017, the LIGO gravitational wave detector picked up 100 seconds of two neutron stars spiraling down towards each other and finally merging. Over 70 light-based observatories, including some high above the Earth's surface, pointed their telescopes toward the event, collecting information across the electromagnetic spectrum. And an energetic system also allows for the creation of neutrinos. However, unlike supernova 1987A all those years ago, none of the neutrinos captured by Earth's detectors could be traced back to this merger. While disappointing, it was not expected. The event was so brief that it made detection unlikely. However, a future neutron star merger may provide an opportunity for photon-capturing telescopes, gravitational wave detectors, and neutrino detectors to work in tandem, providing three different images of the same object, thus marking the beginning of the era of multi-messenger astronomy. Slowly but surely, the previously untouchable neutrino is joining the ranks of particles used to study objects throughout the universe.
Okay, isn't that cool? So, like, to me, it's interesting that there's a supernova. It's like, I mean, it's a star just imploding, from what I understand. And the explosion caused by that causes neutrinos to be sent, like, and detected in the Earth because they're so, I don't know, it's kind of weird, but it's a cool idea that like they're moved by a universe away from ours. I just think that's so cool. Like the idea of like magnetic forces and things like this that are like invisible to our eyes, but are literally gauging and kind of woven through the fabric of our universe is just, I don't know, very inspiring. Okay, let us watch one more trailer because we finished this panel. We have one more panel to go for me to hit my mark for the night. We might even possibly get through 2 panels further, but I think we'll probably get at minimum one more panel through. So first panels come out pretty good. And we'll get there. We haven't finished any other panels than panel 1. So I'm going to play the trailer for the Christmas trailer for 2 stories, and we'll get back to it. And if you haven't yet, hit that like button while we're having the trailer. And then when I come back, we'll continue learning about neutrinos and drawing some cool stuff. I hope your guys' projects are going really well. I'm feeling very inspired and very awake, which is good because it's midnight here and it's definitely a night stream. All right, let's continue. Well, let's watch that trailer and then we'll continue. Welcome back. Let's do this. Let's color panel 2 and listen to more of this interesting what happened to all the neutrons from the history of the universe channel.
And some scientists believe we can even use these invisible particles to unveil something even more distant. The beginning of the universe itself.
Another trailer.
You must think I'm stupid.
Have you lost your mind?
I haven't lost my...
Okay.
This is the cosmic microwave background. Our universe's baby picture. The photons captured in this image describe the entire state of the visible cosmos,
Cool.
a mere 380,000 years after the Big Bang. At this moment, the universe changed from being opaque to transparent. Over the subsequent 13.7 billion or so years, these photons have touched every corner of the universe in a 45.6 billion light-year radius. And in their travels, their wavelengths have stretched out longer and longer.
Cool.
Today, we can only detect them with radio telescopes. Indeed, they were first detected as a form of static, coming from every possible direction in the sky. By studying the cosmic microwave background, otherwise known as the CMB, astronomers can turn back the clock to that 380,000-year age.
Okay, you guys. Again, like a lot of people would like watch this and be like, that's nonsense. But like, think about it. Like even the fact that you have a microwave oven, right? That works is like using the same science. Anyhow. So it's cool that the cosmic microwave background, it's like these little undetectable waves are literally generating a map that can give people a picture of the beginnings of the universe is so cool. To me, like, I never was a big fan of math. I wish I had had a math teacher that had kind of explained the giganticness of what math is, like anyhow. Okay, let's continue. But I think like when you consider what is being viewed here, it's just kind of stunning. Okay, let's continue. And that's also really cool. That would be a fun I almost want to use the cosmic microwave background just as a cosmic background in one of my illustrations. Okay, let's continue.
With light, we can go no further. To peer beyond the CMB, astronomers must rely on a different particle, one which freed itself long before the photon did. They need to capture an image of the C-nu-B, the cosmic neutrino.
Oh, nice. Also, Thomas was saying that's the premise of Star Trek as well. Yeah. So Star Trek is heavily influenced by science. In fact, I've heard many scientists give talks about how stunningly a lot of the like science in the science fiction of Star Trek, it's one of the reasons like people who are real science nerds tend to be really into Star Trek. It's like unusually a little accurate, and what it's depicting are actually like potentially possible things. It obviously gets really silly sometimes, but like the point being, like it's definitely like Star Trek is a story that would be like metachlorians would be in Star Trek, and it would fit Star Trek, right? Because Star Trek's a much more kind of analytical story. It just doesn't fit in a story like Star Wars. But yeah, I mean it's like a very thoughtfully crafted, definitely heavily influenced by, a layman's read of physics and stuff like that, and like just kind of getting inspired by these things to kind of craft a whole, how would space travel work in far distances and what would fuel the ships, and A lot of questions like that can derive from just basically just pausing and kind of reading a textbook for a little bit or watching a documentary. Okay, let's continue.
Neutrino background. As the very first second entered the annals of history, the universe had already experienced quite the cosmic ordeal. It had gone through inflation, distinguished the four fundamental forces, and quarks had either combined to form composite particles like protons and neutrons, or annihilated with antimatter twins. Neutrinos and antineutrinos were just part of the hot cosmic soup, thrashing around, colliding with other particles, including photons. They were not the ghosts we know of today. It was simply too hot. Neutrinos were effectively coupled to everything else, scattering with each collision rather than passing through matter as if nothing was there at all. But space was ever expanding. The density of particles in each minute portion of three-dimensional space ever dropping. The time between collisions was getting longer. Particles themselves were slowing down and decreasing in energy. And that decrease corresponded to a drop in temperature. At 1 second old, temperatures had reached an order of 10 billion degrees Celsius, a temperature completely incomprehensible to us, a temperature 1,000 times more intense than what's found at the core of our sun. But, finally, particles were zipping around just slowly enough for neutrinos to break free. They no longer crashed into quarks or electrons or even light itself. The universe was still opaque at all wavelengths of light, as it would remain for hundreds of thousands of years, but for neutrinos, all had been made clear. And this cosmic neutrino background, were scientists able to image it, would reveal the state of the universe at this very moment. The universe at 1 second old. In the interview...
Okay, isn't that cool? So here's the thing too. Because I know, like, I have a variety of people who watch my stream, and like, people pretty much know I'm like a Christian. So it's like, I actually believe in like a created universe. But I actually think, I've always thought this, and you know, you're free to think whatever you want, but I've always thought that even the existence of like a Big Bang is a really interesting thing to me, coming from it from like a perspective of somebody who believes in God or whatever, because it's like, I mean, literally, like, even their explanation of like the earliest microwave background kind of map just kind of being traced by light. And I don't know, it's interesting, like the idea that like the Bible's like beginning is like let there be light. I don't know, it's just interesting. I don't think it rules out, I don't think they have to be incompatible. I tend to think that whatever your view on life is, or whatever your faith is, or whatever your kind of philosophies are, truth shouldn't be able to negate truth. So if what you believe is true, then it needs to be compatible with truth, right? And so like for me, it doesn't scare me like checking out science and like hearing interesting things that, like, again, are so accurate that they were able to kind of generate the most powerful bomb ever known to man. To me, I don't think the things need to be incompatible. And I think if they are incompatible, you have to really do some deep thinking about like what needs to go and what needs to stay. You know, it's interesting, but to me, I never fear the idea of exploring truth, you know? So, but I wanted to clarify, you know, I think it's possible to be like, to have the views be compatible.
Intervening years, these relic neutrinos have continued to lose energy, but they are still out there, everywhere, evading detection even more intently than the high-energy neutrinos our technology only occasionally
Like
captures.
a second
But we
after
do
the
know
universe started?
they are there, and our only hope lies in a method of indirect detection.
Or Obi-Wan Kenobi.
Relic neutrinos, when they first began streaming through an otherwise opaque universe, left tiny sonic booms in their wake. Small patches of space would become slightly hotter or slightly cooler, with the small shuffling around of matter and light. As space expanded, these patches would have too. Therefore, a relic neutrino's influence would be made apparent within the structure of the cosmic microwave background, and even in the overall structure of matter in the universe to this
Dude,
very day.
cool.
Back in 2019, a team of scientists hunted through the structure and announced the inferred presence of relic neutrinos, yet not enough to compile an image of the C-nu-b. Other hopes for detection lie in a special kind of hydrogen atom, known as tritium. Where the nucleus of a traditional hydrogen atom is a singular proton, tritium also contains 2 neutrons. It is a naturally unstable atom. The weak nuclear force ultimately takes control, converting one of the neutrons into a proton, electron, and antineutrino. But decay can also be triggered by outside forces, specifically by the collision and absorption of an incoming neutrino. And it is the energy of that neutrino which dictates the energy of the escaping electron. The electron which our technology can measure. A relic neutrino created in the Big Bang will produce a different signature than a neutrino created by another, much younger source. With enough tritium, our scientists may be able to build up a vision of the cosmic neutrino background. But the challenge that lies within such experiments is the sheer scale required.
Okay, so what's cool is it's also telling you what's at stake with Thomas also said an interesting thing I want to highlight in the chats. He said a Navy tech, while working on a radar installation, noticed a chocolate bar melt in his pocket. Microwaves were born. How cool is that? What's funny is even if he wasn't at a radar installation, a chocolate bar is going to melt in your pocket. Like, so it's kind of interesting. I'm just saying that's funny because chocolate tends to melt. Maybe it's just because I'm in California, so like our cold weather's like always in the 70s anyway. Thomas Adams said, plus all the nerds working to make the tech in Star Trek happen. Yeah, 100%. Well, I mean, so there's also like the classic story of like Jules Verne, you know, writing about submarines before submarines existed. And like, was it Jules Verne being somewhat prophetic in his writing? Was it imagination of Jules Verne that made somebody want to actually make a functional submarine? You know, it's one of the cool things about creativity, you know, and design, because creativity and design, you know, not only lead to works of art, but they can inspire, you know, some really great things. They can inspire horrific things too, but you know, that's something to keep in mind as an artist. You can inspire people to do amazing things or horrible things with art, and that is a little bit of the power of art. Okay, let's continue here.
The Katrin experiment in Germany uses 20
panel.
micrograms of tritium and hopes to detect, at most, 2 relic neutrinos.
Okay, so just look at this thing. Sorry to like pause it, but look at that machine. Look at the structure of that thing. I mean, if that doesn't make you want to draw, I don't know. It's just it's wacky. Truth is stranger than fiction quite often.
In an entire year. The Ptolemy experiment at Princeton, meanwhile, hopes to expand their prototype detector, an atom-thick layer of tritium atop an atom-thick layer of carbon, both the size of a postage stamp, up to 100 grams of tritium. Their team estimates they might then capture 10 neutrinos a year. So much effort for so little data. With a picture of the universe at 1 second old instead of 380,000 years, scientists will be able to confirm or contradict decades of mathematical theory, how physics is supposed to work beyond the sight of our eyes or any of our current telescopes. The secrets behind that barrier are simply waiting to be uncovered. Just like the cosmic microwave background permeates all of space, the cosmic neutrino background envelops us. Scientists estimate that there are approximately 300 relic neutrinos and antineutrinos streaming through every cubic centimeter of space.
So, is that not the coolest thing? They haven't even gotten into the interesting part about neutrinos too, because they shift. I don't know if they've gotten into that yet. I think this might just be like a general, like, this is why neutrinos are really important. This is kind of, but they haven't really gotten too much into like there's anti-neutrinos. That's interesting. But from what I understand and other stuff I've watched on neutrinos, because I haven't watched this one before, I'm just giving you guys a fresh commentary as I am introduced to this documentary. But from what I recall, there's like a weird, it's kind of a unique particle in the sense that it can kind of exist in like 3 forms, which is really interesting. So here in Vegas, you can't buy chocolate covered cookies in the summer. You get one big blob before you get home. Yeah, we're probably in really similar atmospheres, because I'm in the high desert in California, and it's like, and you're in the desert in Nevada. I'm sure your temperatures probably get a lot more extreme, but I'm guessing we actually probably have very similar climates. And so you probably get those like cold desert nights too, because we do get cold desert nights. Not right now, but throughout the year it can get really chilly. But it also, Nevada, Arizona, those are like the places that are somewhat similar or worse than the climate I have here. But here's the cool thing about the desert that a lot of people don't realize. The air quality is so much better here. Oh my gosh. It's like, it's funny. If I go down to LA, I'm just like, how do people live in this smog, But anyhow, let's continue.
But not
also the
all
stars
of these neutrinos
look really cool in a desert. There's like no light pollution where I live.
Over the latter half of the 20th century, scientists discovered that there was more than one type of neutrino. 3 flavors were identified and named after other fundamental subatomic particles.
Okay. So they're getting into cool stuff. I was a little disappointed they hadn't gotten into the 3 thing, and now they're doing it. Oh, you guys have no idea how cool this is. What's funny is, like, if people are watching this currently or after the fact, they're probably just like, this guy is a nerd. But you know what? I totally am. I own it. Okay.
Electron, muon, and tau. The electron neutrino is the most well-studied of the set. Along with their antimatter twins, they are what's created when protons or neutrons inside our everyday atoms interact with the weak nuclear force. They are what's created as the sun shines. But these are not the only secrets that neutrinos hold.
Ooh.
For they have also found themselves at the center of controversy.
See, it gets
controversy
deeper, guys.
that has shaken the very bedrock of physics.
Yeah, this is why neutrinos are cool. Okay, it's getting into it. I love it. They blow our minds, guys.
Since 1905, humanity has been taught that there is a fundamental speed limit to the universe. Einstein's special theory of relativity dictates that no particle or wave can traverse space faster than a particular speed. Light traversing the vacuum of space can travel exactly at this speed limit, which we, colloquially, call the speed of light. Neutrinos, once thought to be massless, travel at very nearly the speed of light, but certainly not faster. Or can they? In September 2011, a team of physicists announced that they may have proven Einstein wrong. The Opera collaboration had observed a beam of neutrinos making the 730-kilometer voyage from CERN in Geneva, Switzerland, to the Gran Sasso National Laboratory near L'Aquila, Italy, and the beam appeared to travel about 60 billionths of a second faster than the speed of light. In another universe, this result could have been the last snowflake to fall before an avalanche, the straw that broke relativity's back. But dissenting members of the team, as well as other international groups, rushed forth not to confirm their result, but to find where they went wrong, where some kind of error could have been introduced. After a review, scientists identified a possible culprit: a fiber optic cable which connected the GPS technology tracking the neutrinos' journey and the computer meant to record their arrival. The connection was ever so slightly loose, introducing a bit of lag in the message from one device to another.
Okay, guys, this is why. Like, I know it's weird, but you know how they were like, "Oh my gosh, this would have like unraveled, the current existing concepts of physics or whatever." So, what they just described is the value of peer review. Peer review is like the big secret of why science works. It's literally when you come up with a result like that that's like, man, we just proved Einstein wrong. Which, by the way, he's been proven wrong on some things. But what's interesting is before everybody just accepts it, even though it's a pretty legit experiment, right? Like, there's peers that see this study in a journal and then review it, right? They're like, okay, let's look over it. Let's see what could have gone wrong here before we throw the baby out with the bathwater or whatever. And lo and behold, they find out there was an error. Now, who knows? Maybe this went further and they found out that, like, maybe it's been detected that way in other studies. But again, that's why it's so important to have falsifiability in tests and also peer review, right? Because you can catch an error like that where it's like, oh, there was a loose cable. Okay, let's continue. Adam Lore said, just tuned in. How's it going? It is going well, Adam. We are listening to a thing about neutrinos, one of my favorite particles on the planet in the universe. And they're fascinating and interesting to me. And we're just getting into like the triune nature of neutrinos, and they're talking about how they might have potentially broken Einstein's theory of speed of light. Physics stuff, nice. Yes, I'm an armchair. It's just fun to listen to, and it's inspiring, honestly. For what you're working on, Adam, and for what the hundreds are working on right now, this should be like almost required listening. Because if you're writing science fiction, dude, there is nothing better than just listening to some stuff on physics and just letting your imagination run wild with this stuff. Okay, let's continue.
Another error was identified in the master clock,
Peer review,
each
guys.
tick passing just a tiny bit too quickly. Together, these errors could explain the apparent violation of the rules of nature.
This is where they're going to introduce
subsequent experiments affirmed Einstein, and the following March, 2 of the project's leaders resigned after members passed a vote of no confidence. Neutrinos, it turned out, did not travel faster than the speed of light.
That's good.
They did not break that law of physics.
That law.
But why would anyone think that a neutrino could break a law of physics?
It's a good question.
Well, they had done it before. The year is 1968.
Wait.
Deep beneath the surface of South Dakota, housed within the Homestake gold mine, sits a vast, shielded neutrino detector filled with 40,000 liters of chlorine-based cleaning fluid. This detector's neutrino target is not man-made, as with the earlier Project Poltergeist, nor intergalactic, as with the later Kamioka ND.
Okay, let's pause here. You guys, neutrinos break physics, okay? How cool is that? Like, this is the coolest thing in the world. If you don't think neutrinos are interesting, it's just, Adam said, I've been working on my story a lot today, and it's important for me not to just defy the laws of physics cheaply to cheapen my story, unless it truly comes from saying something important and philosophical. Cool. Okay, let's continue. But like, how freaking cool are neutrinos? The more I've like ever read or watched about these, I just fall in love with neutrinos. I think they're one of the most fascinating things.
But somewhere in between.
And we're going to let
all-in-one essential tool for managing my
YouTube
business.
video that I'm commenting on get
Allowing
the
me to
revenue
manage my
from their
renovation
ad,
cash flow, send
at
invoices
least
to my
till I can
clients, and
skip
keep
it.
my payroll.
I just don't want to cheat the revenue system for them.
The crushing mass of a star compresses the hydrogen at its core with such an intense pressure that temperatures reach tens of millions of degrees. Along
Sounds
with a
like a
quirk of quantum
comfortable
mechanics,
place
this
to be.
heat causes hydrogen nuclei to engage in a multi-step process, which makes helium. But helium isn't the only byproduct. A continuous
snap.
stream of photons is released, and a specific flavor of neutrino is also created. Electron neutrinos. By the late 1960s, theoretical...
Let's pause here. You guys, neutrinos have 3 different forms. Even that in itself, like the way that neutrinos exist in 3 different variations, in itself, from what I remember, breaks physics. But let's continue.
Physicists had calculated the amount of electron neutrinos the sun would emit in any given second, as well as how rarely these neutrinos would interact with matter as they barrel through the Earth. Astrophysicists Raymond Davis Jr. and John Bacall knew what to expect. But when the count finally came, it was only 1/3 that estimated value. Davis and Bacall had a mystery on their hands. A mystery that would come to reshape our understanding of the fundamental particles that govern our universe.
Dude, neutrino.
At the time, the result
neutrino
was so
power.
unexpected that many believed there had been some kind of mistake behind it, as with the later opera collaboration's results regarding faster-than-light travel. It was just a single experiment. Human error could have caused the discrepancy, or the estimated number of neutrinos made by our sun could have been off. It was, after all, a very complicated calculation. A 1% error in the sun's temperature would lead to a 30% error in neutrino count. But as the years passed, and experiment after experiment around the world continued to replicate Davis and Bacall's results, it became clear observations didn't match theory.
Let me pause. Roll for Tarako said, sheesh, the ads on YouTube lately. I clicked on the stream and an erotica webtoon ad played. I thought Josh changed his format. Well, I mean, I have been doing erotica webtoons lately. That was one. That would actually be really funny if I'm like, by the way, guys, I'm going to play a trailer for my erotica webtoon. No, I don't, unfortunately, I don't have control over the ads that play on YouTube. But if you watched an ad on my YouTube channel, I appreciate it because I get a little bit of cash for that. So much appreciated. But yeah, hopefully you were able to skip it at some point. Okay, let's continue.
The fundamental theory behind the nature of neutrinos was somehow wrong.
Boom.
But it took nearly 30 years for the remarkable truth to be found.
That's right.
In 1998, one of Kamioka NDE's successors, Super Kamioka NDE, completed a study of atmospheric neutrinos. While it was primarily sensitive to electron neutrinos, researchers had their sights turned towards its sibling, the muon neutrino, created when charged particles from both the sun and the wider universe interacted with the Earth's atmosphere. But their research uncovered some quizzical...
Frank said the erotica art casters. It would be the eroticasters. Which, by the way, don't Google search that because that might actually be a real thing. Okay, let's continue.
Cool. Data. The number of neutrinos detected coming from one side of the planet didn't match the number coming from the opposite direction. Given their ghostly nature, the number of neutrinos detected should not depend on the direction they're coming from. It should be constant. And it was here that the researchers suggested a bizarre new idea.
I love this.
Something was happening during the muon neutrinos' journey. In between
Yes.
being created in the air and striking their detectors, some had somehow changed into a third flavor of neutrino.
Okay, this part, by the way, pay close attention to this. One of the coolest things about the neutrino that's very unique to the neutrino and made me obsessed with neutrinos. Okay, let's continue.
Their detector wasn't sensitive to the tau neutrino. The slightly longer distance the Earth-traversing neutrinos had to take gave them greater chance to swap identities, and thus go unmeasured. Further experiments at the SNO in Canada verified the results, and it was conclusive. The sun's missing neutrinos, first identified by Davis's team, had been found. 2/3 of the electron neutrinos had turned into muon or tau neutrinos.
Isn't that cool?
At any given moment, any one flavor of neutrino could change into another.
Isn't that awesome? That's impossible.
And in 2002, Davis and Koshiba were awarded the Nobel Prize in Physics for their initial neutrino detections. And in 2015, Koshiba's protege and director of Super Kamioka NDE.
So you know what's weird is like I'm. That's a good question, Adam. What is your favorite flavor of neutrino, Frank? I think the cool thing is whatever your favorite flavor is, it can just change whenever the hell it wants, and they can't understand why. Isn't that cool? I don't know. I just think it's, I don't know. I'm a nerd. Okay, let's continue.
Takaki Kajita shared the prize with SNO researcher Arthur MacDonald for their discovery of neutrino oscillation, continuing the remarkable international effort.
Hell yeah. Oscillate your neutrinos,
The principle
guys.
of neutrino oscillation had solved the solar neutrino problem, but at the same time threatened to rewrite the laws of physics. In answering one question, they had opened up so many others.
Isn't that cool?
The revelation that neutrinos could oscillate between one of three flavors meant that neutrinos had to have mass. But under the standard model of particle physics, neutrinos should be massless. Complicating this further, in addition to 3 neutrino flavors, there are 3 neutrino mass states. But unfortunately, there is not a one-to-one correspondence. Instead of having a scoop of vanilla ice cream having 1 mass, a scoop of chocolate having the 2nd mass, and a scoop of strawberry the 3rd, each flavor of neutrino is a Neapolitan scoop.
Dude, okay. How cool is that? The masses are different. It can tangentially just kind of shift. I love it.
With different ratios of vanilla, chocolate, and strawberry. Scientists aren't even sure what this mass is. Experiments using nuclear decay having narrowed down the mass of the 3 states to less than 1 electron volt. For context, the electron itself has a mass of more than 500,000 electron volts. If neutrinos do have mass, they are dwarfed even by the minnows of the standard model. Despite this, because of their sheer number, some estimates would put their total mass as roughly similar to the mass of all the stars in the universe.
Isn't that crazy?
The other major unknown, of course, is how neutrinos have mass at all. The universe, in its potentially infinite size, is filled with a variety of similarly infinite fields.
Okay, so let's pause here and just appreciate the joys of, like, they don't know a lot of this stuff, and it's awesome. It's kind of refreshing to hear people talk about exploring and trying ideas and kind of like, I guess my point is it's fun. It's fun. Like, that's the thing I think people miss about, like, science. It can be fun. Because like there's so much, like, even that, like, they find out this thing, they test it, they peer review it, and it has to be true. But for that to be true, it kind of second guesses like a bunch of fundamentals of physics, which is so cool. I just love it. Okay, let's continue.
Fields. We are generally familiar with electromagnetic fields and gravitational fields, but there is one field that imbues anything that interacts with it with mass. This is the Higgs field. It is omnipresent, invisible, and immutable. We only know that it's there by inferring the detection of its particle avatar, the Higgs boson, finally detected to great uproar in 2012.
That was a
It is
huge
fairly
deal.
straightforward. The more a given particle interacts with the Higgs field, the more mass it gets.
Let's also pause and just appreciate that happened in my lifetime. Higgs boson. That was a big freaking deal. A big deal. All right. Let's get our Higgs boson and watch this.
The most massive fundamental particle is the top quark, which receives from the Higgs a mass equivalent to what is contained within a single atom of gold. Particles like photons don't interact with the Higgs field at all, and stream through reality with no mass whatsoever. This would suggest that, as the least massive particles known to humankind, neutrinos interact with the Higgs field, but just barely. But as we currently understand neutrinos, this also cannot be true. According to the standard model of particle physics, as particles interact with the Higgs field, they not only gain mass, but change a property sometimes referred to as handedness, swapping from being right-handed to left-handed, and vice versa. Thus, all matter and antimatter particles within the standard model come in both right-handed and left-handed forms. All, it seems, except for, you've guessed it, neutrinos and antineutrinos. Over all these decades, across all our vast hidden detectors and super-powerful particle accelerators, scientists have yet to observe a right-handed neutrino, or a left-handed antineutrino. This means they cannot interact with the Higgs field as science currently describes. They cannot get their mass in the way all other fundamental subatomic particles do.
Okay. You guys, again, neutrinos are badass, okay? They can't get mass in the way all other particles do. That's so exciting. Why? It's so great.
What, therefore, is the alternative? Given that all neutrinos are left-handed and antineutrinos are right-handed, it may be that neutrinos are actually their own antiparticle. Such particles, of which the standard model only counts the photon and the Z0 boson, are known as Majorana particles. Another option is an addendum to the standard model that would tie the light neutrinos science has observed to a heavier counterpart it so far hasn't. Like sitting on a seesaw, these much heavier neutrinos would sit on one side and lift up the neutrinos on the other, making them lighter. Or perhaps the right-handed neutrinos have merely gone undetected after all this time. Right-handed neutrinos may be even more ghostly than their left-handed twins, interacting exclusively with the Higgs field. Such right-handed neutrinos may also be the answer to another neutrino mystery. Sterile neutrinos, a flavorless type of neutrino that would join the ranks of the electron, muon, and tau neutrino flavors if one were ever detected. Sterile neutrinos, if they do in fact exist, would be even more ghostly than their flavored siblings. They would not even interact with the weak nuclear force, only responding to the force of gravity. The ultimate ghost particle. If sterile neutrinos are one day unveiled as a real-world particle, like neutrinos were 7 decades ago, they may also contribute to the gravitational effect astronomers ascribe to dark matter.
Okay,
and finally,
guys.
it may be that all right-handed neutrinos existed merely during our cosmic origin, birthed alongside their siblings in the heat of creation. Something in them could have been unstable, and over the 13.8 billion years time has flowed ever forward, they would have broken down into other subatomic particles. They would now be lost to us forever, any remnants of them long dispersed. But perhaps there is a method to see back that far. Locked away in ancient structures like the C, new, B, which eventually, piece by piece, neutrino by neutrino, humanity will map.
Hell yeah.
Neutrinos, their elusiveness making them the ultimate cosmic probe, may just help give us the answers to their own secrets.
Okay. So if that didn't make you interested in neutrinos, I like that. Adam said, also known as an impotent neutrino. The sterile neutrinos. Oh my gosh. Okay, I think that's it.
You've been watching.
Okay, guys. So that was by J.D. Voyek and What Happened to All Neutrinos, The History of the Universe. And that was really fascinating and super interesting. I hope you guys got a kick out of that. I don't know what it is about neutrinos in particular. I think it's the fact that they can kind of traverse, like, there's so many interesting things. The fact that they can kind of like potentially switch forms, just with no causation, they can just kind of traverse between 3 different versions of the same thing. The fact that they pass through us undetected, the fact that they can have no effect on matter around them, and yet also have massive effect on matter. There's just a lot of really cool stuff about neutrinos that entertain the imagination. Do the Ninja Turtles have like a neutrino thing? And Frank said he prefers strawberry neutrinos. I would say, like, I like the orange sherbet neutrinos. That's my favorite. Like if I'm, going for like Neapolitan and it's like more of the, kind of like the tropical flavor. If I have to like stick with, I'm kind of with Frank on that. Like if I have to pick in the Neapolitan shake of neutrinos, I think I'd probably go with strawberry too. Because I am a strawberry ice cream kind of fella. What about you guys in chat? What kind of ice cream do you guys prefer? What's your favorite ice cream, guys? Let's stop talking about unimportant things like neutrinos that might give us a picture of the universe at 1 second old. That's not that important. Let's talk about what is your favorite ice cream flavor. I want to hear everybody's favorite ice creams. Everybody. I also missed drawing a line, and I will add that in right now. I also did catch the particle target reference, Adam. I want to make sure you don't think I missed that. Said maybe they'll find a Higgs boson, which I think you were referencing particle target. Thomas said chocolate. Is that your favorite of all ice creams or just of the Neapolitan? Like if you have to take a scoop that's kind of leaning one way, you're going to go to the chocolate. Or is chocolate just like your all-time favorite ice cream? I will tell you, it's funny. Mine isn't the most exciting. I am with like if I have to pick a shake, right? I'm going to go with pretty much a strawberry shake. So I'm kind of with Frank on this. I am obsessed though with ice cream. If we're just talking ice cream, the one ice cream I never get tired of is mint chip. I feel like just a good mint chip is just, man, that's a damn good, like it's hard to go bad with mint chip. Thomas said, then I worked at an ice cream factory for 17 years, so I'm a bit jaded about ice cream. I could see that. Just from working in t-shirts, in the t-shirt industry, it took me quite a few years to even care about t-shirts. Like, I love t-shirts. I've been like a t-shirt guy like my whole life. And yet, after living in the t-shirt world for so long, I had this whole point where even now I'm like way less picky about my t-shirts because I'm like, I don't care if this comes from Walmart. I don't care where it comes. Like, I don't care what, because there was a point in time where I was like living and breathing making t-shirts and I'd like notice all the details on them. But after a while, it just kind of becomes like a job. I think that kind of happens anywhere. I'm sure physicists feel that way. They're just like, man, I'm sick of this neutrino crap. Like, can we just not think about the origins of the universe for a second? Strawberry shake from Whataburger the other day. I will tell you though, if I'm doing a malt, it's got it. Like chocolate malt is one of the best flavors of like ice cream-ish beverages. You know what I mean? Frank was saying, when I was an underwear model, I was so engulfed in this fancy underwear, I just don't wear any anymore. As a handsome artist, I tend to actually wear underwear. That was funny though, Frank. All right, so we are getting a little further on this page. We're at the 2-hour mark, so that means we need a trailer. And this one, I'm going to reach out to you guys. Which would you prefer? Would you like Philip Chandler or Christopher Runciman's or Jim Lujan's trailer? I don't know. Like, neutrinos kind of blow my mind. Physics blows my mind quite a bit, but like neutrinos, there's just something so cool about them. Oh yeah. Okay. Frank said, I was going to ask if Frank had answered the neutrino question. He did. He said the neutrinos are an alien species in the 80s Ninja Turtles cartoon. They look like space elves. I didn't know that. All right, Adam spoke first. Oh, he said physics is really fascinating. Lately, I've been really deep into light and optics stuff. Yeah, that stuff blows my mind. Like, even the beginning of this documentary was talking about, you know, how the sun is actually green. And I was like, that's just that alone is really weird, you know? It's just the fact that, like, there's a whole, like, invisible light is really interesting. The idea of there being this whole visible universe that's not visible to our limited eyes is, I mean, how can that not be super fascinating? Adam spoke first, though. He said Jim's is great. So we will watch Jim's. I also feel like at some point I need to play Joe Biden's too. So maybe we'll watch Jim's, and maybe as we get closer to 2, maybe we'll be able to sneak in a Joe Biden endorsement. All right. Here's Jim Lujan's commercial for my 2 graphic novels called Wordzoid.
Well, Peter, since I'm such a big music fan, I'm going to have to go with Karen Carpenter. Oh, Stu, I'm sorry. That's the incorrect answer. Trish, what you got for us?
I'm going to go with Kim Gordon.
All right, let's check that answer. Kim Gordon. Do we have a Kim Gordon? Yes, and that means you're our new Wordzoid champion, Trish. Dale, tell Trish what she's won. Trish, you've won a copy of 2 stories, a memoir of faith and mental illness. Handwritten, hand-drawn, and handed to you by artist and writer Joshua Kemble. But wait, that's not all. You've also won a copy of Jacob's Apartment, the story of a doomed romance. What happens when you take Eternal Sunshine of the Spotless Mind and put it in a blender with Ghost World? You get Jacob's Apartment, written and illustrated by Joshua Kemble. Trish, thank you for playing Wordzoid.
All right, great job, Trish.
I was told I was gonna get a lifetime supply of paper towels.
So Thomas Adams said a black body curve of the sun peaks near the color green in the spectrum. I love it. The Neutrinos spoke with a high-pitched voice, chipmunk style, and they drove a flying rocket. Oh, I remember them. Michelangelo had a crush on the girl Neutrino. Is there a place you can watch like the old Ninja Turtles episodes? That'd be a fun rabbit hole to go down. I almost feel like Frank, you, me, and Adam should do a drawing stream where we like watch old 80s like cartoons and like do commentary on the cartoons as we're like working on our stuff. So like a good example would be like we could try to like do art hangouts and go through like every episode of G.I. Joe. You know, I think that would be fascinating. And we could work on art at the same time, you know. I didn't even think of that, but maybe we'll do that at least on this live stream. Maybe I'll start digging through some old 80s stuff. The only thing I'm a little concerned about with the commentary stuff, which I'm relatively new to, is I don't want to get like copyright struck. Like, and I'm pretty sure as long as I'm actually commenting on what I'm consuming, I think we'll be okay. Adam said, have you ever seen a film called Victim of the Brain? It has some interesting brain science stuff, and it's a really weird part with Daniel Dennett exchanging his brain with somebody. Ooh, that's pretty awesome. Yeah, the brain is so weird. I mean, like when we were kind of dipping into determinism a little bit, and the idea of that, it was just like such a it's such a head, like it's a head trip to think about, you know. Adam said definitely interesting in regard to the free will and determinism discussion. And what's weird to me is like the interesting thing of like things pointing to a deterministic outcome, but then we have this intuitive sense that's like you can't, like everything can't be predetermined. We have a choice. I experience choice daily. And so our experience is like that of having choice and of having free will. And yet like the science kind of it seems torn in the direction where there are a lot of indicators that there's a lot, if not everything, at least a lot of things that we, you know, attribute to free will are predetermined. So it's like this just really weird dichotomy that's fascinating to me. I think that might be the thing. I think I might be pinning down why I'm interested in philosophical questions that have like contradictions, but they seem like both could be true, even though they're contradictory. I think with neutrinos, there's a ton of that where there's so much contradictory stuff, but like both have to be true. And it's like, okay, how can both be true? That to me is always an interesting like mind game to like at least allow myself to kind of dip down the rabbit hole of. Of course, I'm always careful when dipping into the rabbit hole of those things. Adam said the film is mainly by Douglas Hofstadter, author of Godel Esther Bach. I am a Strange Loop co-author with Dennett on some other things. Nice. Sounds really cool. I might have to rabbit hole that. But yeah, I think there is something really interesting. I think I'm fascinated by contradictions. And I think Adam sent me a link to that movie, which is really exciting. I'll check that out. Thank you, Adam. How are you guys doing? How are your comics coming along? What are you guys working on? That's what I want to know. I am going to try to finish this panel before it hits 2 a.m. And I think I might be able to, because it's not as complicated as the previous panels. And I'm kind of excited about getting a little bit further on this book. It's funny how much of a beast doing a book of this length is. Like, you know, this is not my first rodeo, but there's always this like weird point you hit when you get to like page, like you're getting closer to 100. When you get closer to 100 on a comic, it's just like, it's very much like that tiring part of a marathon where you're like, you know, at this point, you know, when I get to 100 on this, I'm like halfway through. And that's a scary thing when I'm like this close to 100 and I'm starting to feel that like, oh, like, not that I'm not into it. It's just like you have to kind of think of ways to retain momentum and celebrate small victories along the way, because it's just like a slog to make, you know, that many pages of anything. But it's also very exciting because you also see this story like fully fleshing out. And I think that's the thing that keeps it interesting is, you know, like if you're ever working on like a long form comic, you know, I think a lot of people think about that and it's very intimidating for a lot of people for that reason. Because it's like, dude, how do you, you know, keep interest after page like 50, you know? And it's like, I think that's how, is like you have to kind of take joy in the fact that you're finally being able to see a fully realized story, like as it's playing out. And so there is this really cool thing to like what you can pull off in 50 pages as opposed to what you can pull off in like 3. And it's vastly cool because you can afford to do slower pacing. So you have a lot more control and options with timing and stuff like that. And there's also the option of like having scenes that really develop characters and be able to really get into like character driven stories. But it's like, to me, that's the big challenge at this point that I'm at with Not Death But Love. It's just like maintaining interest and momentum is going to be a real challenge. And especially after a day like Mother's Day, where, you know, most of the day I was just doing family stuff and stuff like that. And I allowed myself a day off from comics. And it's like, that's the danger zone for where I'm at in my book, is like, I can't allow myself too many days off of comics because I will lose that kind of vision of like where I'm at in the story. I'll lose the energy and the momentum. And then like, there's always just a possibility that, you know, it's almost like slowing down too much in a race where you can kind of lose momentum and then lose focus and lose track of the whole goal in the first place, you know? So that to me is the big challenge. Oh, this is awesome. Adam said, I got a lot of writing done today, like getting into detail on emotional depth and dialogue. Nice. And he said, and getting more precise with wording things, like trying to get a solid, memorable lines for my whisper character. I love it. Thomas Adams says, I think Asimov had an interesting take on determinism. He called it psychometrics. You can predict what an individual will do, but humans in mass, I think maybe you meant you can't predict what they will do, but humans in mass can be predicted. That is interesting. Yeah. No worries, man. Thomas, I don't know if you caught my stream the other day. I have this idea. I gave the prompts to Christopher because I don't think I'm going to have time to see that idea through. And maybe Christopher would find it fun to work on. But I love the idea of like Because autocorrect and stuff like that, it's just such a like part of our lives now. I was realizing like there's gotta be somebody who like a relationship was destroyed or somebody got murdered or something horrible happened because of autocorrect. Like I guarantee it, with how much communication causes so much conflict, like miscommunication is like one of the biggest sources of conflict in the world. I cannot not imagine that there's got to be a scenario where I don't know, like some guy's like sending his wife like a really sweet message about their anniversary or something, and autocorrect just makes it like this unforgivable thing that he says that like ruins their relationship, or like, you know what I mean? I think autocorrect has to have caused some kind of havoc, like I mean actual harm in the world. I was just thinking about that, and I thought that was just it, dark but also very funny. Like the idea of like this hugely serious conflict happening because of autocorrect. I just realized I have her on the wrong couch here. Man, I was off my game. Like, why is she on the wrong couch? Gotta correct my drawing. Okay. We may not finish this tonight, guys. But we're gonna do our darndest. I'm gonna correct that while I've caught it. It's so funny how I catch myself doing stuff like that quite often. With long form comics, I'll find times where I just like defaulted and drew the wrong background. And it's like very much a thing that'll happen. So we have to kind of correct the couch to the other couch, and I think that'll handle most of the issue here. Make sure I'm doing it in my rich black. That is a fascinating idea, though. Like the idea, I've heard a couple people try to kind of navigate around the whole conflict of, determinism versus free will. Some interesting arguments, or compelling ideas. Because, like, by one argument, which is really interesting, it's almost impossible to argue against determinism because, to an extent, like, once something's happened, it's like there is no alternate. Like, the past is kind of fixed in stone. So one cannot go back and change the past unless you believe in, like, I guess there is the whole idea of like multiverses or whatever. But it's like assuming that like the past is fixed. That would mean the future is technically kind of fixed. I don't know if that makes sense. And if the future is fixed, you could technically have a choice that you were always going to make, but still have made the choice of your own volition. It's a hard one to like stretch my brain around, but I think it kind of works logically, even though it's very contradictory. So if the future is kind of written, but you actually have free, like, my point is, if like I'm always going to make the same decision, but it's still my decision that I make, it's just always going to be that decision. It's still a decision. Kind of a weird one to wrap the mind around. So if the past is fixed, right, that means that there's a potential that the future is fixed. Like, meaning once something has occurred, once the future becomes present, it's fixed. I don't know if that makes sense. Because all the future is like unwritten past. So I'm stretching to kind of make this one work and explain it. But it's like, so there is a world in which you could have a fixed future where you're always going to have the same result of choice. no matter what because of your situation, but you could still technically have free choice. Because just because an outcome is known doesn't mean an outcome is without freedom. That's sort of weird. I'm stretching. I don't know if this is making any sense. Keep in mind it is close to 2 a.m, so it's a fun mental exercise. It's fun to try to do the gymnastics to make that work, but it does require some gymnastics. So the reason that the argument that I've heard for like a fixed future is the idea that like time itself is sort of a perception, and like again, like the fact that like you can observe the sky and look back like 1,000,000 years, you know, in time suggests that you could technically like possibly look forward 1,000,000 years in time. Like a timeline could already exist. Time is such a strange thing too. So the like even the definition of like what happens when you get to like the event horizon of a black hole, and the fact that like it causes like time to kind of break down. They've speculated that if you were on the event horizon of a black hole, that you would just infinitely recurringly be falling, like before you even die, like assuming, I mean, obviously you'd be dead before you got there, but just hypothetically, like even if you were to get there, say there was like some spacesuit or something that allowed you to be at the event horizon of a black hole, you'd just eternally be falling. Because time can kind of like cease to exist. So even if the events are already there, that's kind of something I kind of actually subscribe to. There's still a world in which you can still have free choice. It's just the choice you made has already been made. But it's still a choice you made. It's a hard one to wrap the mind around. I don't think I'm explaining it the best. But my point is like, because of like it, regardless of, you know, whether it's predetermined or not, doesn't necessarily negate free will, even though it kind of has to. It can kind of do both. That's my own philosophy on it. I don't know how exactly it works. Adam said it's hard to explain, but it makes sense. Yeah. Because I feel like it's one of those scenarios where like both kind of need to be true philosophically. I guess there are ways where you could consistently justify determinism, but the problem with that's inherent, that makes everybody uncomfortable, is if you do that, if you buy into like a fully deterministic outcome where you have no free will, then it kind of puts into question all of ethics and morality, to like an uncomfortable degree that I don't think anyone philosophically would accept. Even like the most stringent people, I think, would have difficulty accepting that. So I'm trying to think of like ways where it could work. Like, okay, here's a good example. So let's say today, you're a time traveler, right? This is where time stuff gets really interesting. I'm just doing a mental exercise here. And again, I'm no genius, so my mental exercises may not be that interesting. But let's play with this idea. So in the present, I wake up, like tomorrow, I wake up and I choose to make coffee, right? And at that point, it's kind of unwritten. It's not certain. So it's kind of a free will choice. This is just hypothetical, right? It's a free will choice at the moment that I make coffee. I'm like, okay, I chose to make coffee this morning. But a minute later, if I could go back in time and observe the event happening, it's fixed. Like, there's no other way it could have been because the past is written. So it's immovable. So by that logic, that means that in the present, when I make that choice, the second I've made that choice, it's already a fixed past, which is immovable and unchangeable. And so it can both be fixed and free. I don't know. I'm working it out in my head, but to me, that as badly as I might be explaining it, I think that makes sense. I think that actually works. But I do think it like logically kind of makes sense that if the past is immovable, like I can't go back and change my trajectory. There's nothing to suggest that that could be true, where I could like go back in time and like, as fun as it is, even people who've speculated like time travel suggest that the most likely scenario for time travel would be to be able to travel to the future. And a lot of people who think that traveling to the past might be possible have speculated that it would be immovable. Like, not that you could cause a rift or something in time, but that in itself, you know, it would be immovable. If you couldn't cause a rift in time, you wouldn't be able to change anything in the past. And if you change something in the past, you know, it's why all those sci-fi movies talk about like breaking the time stream continuum or whatever. So my point is, if the past is deterministic, I think that would indicate that the present is both free and determined. Because the present always becomes the past. So whatever decision you make today will eventually be something that is determined and cannot be changed. I don't know if that makes sense. I'm playing with the idea here. But that's part of why it's an interesting conundrum to like play with. Do you think following through on previous decision is a form of free will? Like, first the decision is free will, but continuing to do it is still free will. That's an interesting thing too, because like I do think there are things that are free will, and then I think there are things that aren't. Like I think more things than we like have a lot to do with our environment. And I think that's just the case. I think, but being a parent makes me believe more in nature than just nurture. A lot of people I know believe in like the whole nature versus nurture argument, where it's like how much of like a kid's outcome in life have to do with like, and their personality and stuff like that, and their morals, all of that have to do with like formation in nature, and then how much of it has to do with like the outer external environment. And what's interesting is most parents I know, and this is I know this isn't gonna like hold up in like I know I'm committing a logical fallacy here, right? Because I'm just talking about my own experience and anecdotes, but anecdotally I can say that most people I know who believe in the idea of nature over nurture, or sorry, nurture over nature, haven't had kids. I mean, obviously it's both a little bit, but the people who sway more on like nature really dictating everything about a kid's personality, it's just a hard one to buy when you have a kid, because they start displaying these personality traits. They're so like you can have two kids born in the same conditions with like almost identical genetics, and like they just inherently have like different personalities. It's one of the most interesting things about people. However, right, like, yeah, I mean, like somebody born into like extreme poverty is going to have a more specific outcome than somebody born into extreme wealth. Like there are some indicators that are environmental that like will inevitably have similar patterns and effects on people. So it's like this is kind of weird thing, but I do think, given that I do think there's a lot of just like things that are kind of baked into the cake when we're born, like and are almost like written, you know, about us before we're even able to like make decisions. And then there's definitely environmental factors too. So it's like this weird, I don't know if that answers. One time my friend and I were discussing this and started trying to prove we had free will by painting our hair and putting books in the refrigerator and just throwing shoes across the room. But what's funny is like from a deterministic perspective, that's even that chaos was like it was inevitably going to happen. Continue. Yeah, that's a good point. Thomas said, I heard this on YouTube. Parents are not engineers writing on a black slate, but shepherds. The shepherd is very important because they pick the fields the sheep graze in. I agree with that entirely. And like that definitely is going to have an, you know, it's like that's a really good way of putting it, because your way of like rearing a kid will have a huge impact. Like I think a lot of people my age, like honestly myself, like everyone I know, even if you have the best of parents, you know, you as an adult are such a formation of like all the weird things that happened to you as a kid, or all the like, even the best parent, there's going to be like these moments where the parent's just not perfect and it like scars you a bit. Even the best parents, or there's going to be moments that like interactions you have with other kids or whatever that just kind of haunt and linger like for your whole life, or positive experiences and interactions, or like a good teacher you had or whatever that like lingers for like the rest of your life, and has like a real playing, it's like a real piece on the chessboard that kind of moved your life in a specific direction. And so like you're in this path of life where you're making choices, and they're conscious choices where you have multiple options and you make a choice. And it's very clear, you know, in your own subjective experience that you have multiple paths you can go down and you pick one. But all of those different external factors are affecting whether you're going to pick left or right, you know. However, there's still also just innate things about you that are going to help you pick left or right. And then there is chaos and chance. But in a deterministic world, you know, even what appears as chaos and chance is kind of determined. And so it's, you know, it's just like a really interesting, I'm not going to solve the whole determinism versus free will thing, but it's just a really fun thought experiment. Is there any action that could ever demonstrate free will? Is whether we have free will not falsifiable? The question is free will falsifiable? Because I think the idea of determinism is very, I don't know if that's falsifiable. I think that's why it's philosophical. Now, if they found, you know, I think it would be potentially provable, but I don't know if it would be falsifiable. And that's why it's a hard one, and it's more in the realm of philosophy, even though they're trying to bring it into neuroscience. Because I don't think neuroscience and philosophy have fully overlapped. They're getting close, but it's like I don't think they understand the brain to the extent where they've been able to fully integrate the science of philosophy with the science of like neuroscience. That's like one of those weird scientism things that, again, doesn't always have to remain scientism, but the idea that like science in its own pure form could make that hop from science to just pure philosophical questions or ethics questions that's a leap. They haven't built the bridge yet. I'm not saying it could rule out building that bridge, but I think that's where you'd err as like even a neuroscientist to make that leap. However, to be exploring science guided by philosophy is not a bad thing. If you're curious about determinism, and so it kind of guides you in your study of the brain to where you're like, what kind of experiments could we do to kind of test determinism? That's a great thing, right? You're going to learn a lot of information. What could we do to test free will? But yeah, I don't know if it's falsifiable in a lab yet. Now, I mean, if they found, like, there used to be an idea of like a genetic code predetermining everything, and they've already kind of ruled that out a little bit. Genes definitely have a massive impact on our lives and our behaviors, but they've ruled out the idea that it has the impact on all of our behaviors once they kind of decoded the genetic code for humans. But it's like, I don't know, like, it's funny that we've gotten like so good with DNA, but like the brain is still just this monumental, it's like this giant cliff that we haven't even come close to like cresting, like, or wave, I guess. It's interesting. That being said, it is 1:35 and we finished those three. Oh, this is interesting. Thomas said, I heard this on YouTube. Wait. We already talked about that one. Adam said, a determinist who doesn't believe in fruit. Oh, okay. Sorry. Thomas said, like me, for example, my mother was an English nut, Shakespeare in the lot. Mine too. And he said, my dad was into hunting and fishing and construction, and little old me big into science and engineering. Nice. No one else in my family like that. Yeah. And I mean, like, Ben, my son, is like really good at math, abnormally good at math. And there's some genetic stuff we have in common. Like, I think my son and I are, I know my son is autistic. I think I might be as well. And that we have a lot of commonalities in that. But I've always sucked at math. I've always been awful at math. My wife isn't that great at math. And like somehow... my son is like we had him, like take his gait test or whatever. He's in like I forget. It's like, there's like 2% of people on the planet that are his age that are as good at math. So he's in like the top percentile of people. And that's crazy. That's stunning. Like, I wasn't that smart as a kid. Like, I was pretty smart as a kid. I got like straight A's and stuff like that. And I think tested pretty okay. But like, I don't know if I was like in the, like top 2%. So where does that come from? I don't know. And then also just his interests, a lot of them just come from, him. Like when he was little, he used to like just memorizing alphabets, like, and I'm not just talking about like one alphabet. It's like he knew 5 different languages alphabets. When most kids were struggling to learn like ABC, he was like speaking like in all, like he knew all these different languages alphabets. And we bought him like these little alphabet blocks because he just loved them. Like, not blocks, but those little pad things that kind of go together. But we got him like the French one, Japanese, we got him Indian, like, and he just learned all these different languages. And it was just like, how, like, he learned, I can't remember if it was Farsi or something. Like there was like just a bunch of weird languages that he learned that were like all sorts of different. It's not like they were all from the same origin point. And he just enjoyed that. Like that's not something we got for him to kind of encourage it. It was something he like wanted. Like he wanted to learn and memorize all these different alphabets. Where does that come from? You know? I don't know. It's anyhow. My point is, like, as a kid, I had like weird quirks and potentially like some pretty autistic traits, but I didn't have that one. And so it's like, I have no idea where that comes from. I do know we read to him a lot as a kid. So maybe, you know, maybe that was a little nurturing, but it's like, it's just bizarre, you know? Devangari might be the Indian letters. Yeah, I think so. But he knew like that, like he just knew the full alphabets and could recite them. Like, and he learned all the songs and stuff. It's bizarre. And I mean, it makes sense as a kid, like for that to be a little easier because like we're more malleable with language. But yeah, there's you know, that's just my own experience with my own kid. But there's definitely things about him that are just like very much like his mom and me. And then there's things where it's just like it's his own unique kind of magical thing. Okay, guys, we've been going for 2 hours and 40 minutes. This is really fun. I appreciate that you guys hung out, and I hope you guys are as excited about neutrinos, or at least can see why I'm so stoked about neutrinos, and also confused. But also I love learning about them. We finished, we overdid it, guys. I was hoping to, at minimum, get 2 panels done, and we got 3 done. And I appreciate that. And I have to thank you guys in the chats because you guys are partially responsible for why I got to 3 instead of 2. Because I love the conversation we're having in the chats. Make sure you guys check out Adam Lore's channel. Thomas Adams, thank you so much for all the cool just knowledge, you know. That's pretty cool. And I like that you I suspect, Thomas, like just from comments you've made in the chats and stuff, I think you're much more informed on science and engineering than I am. And so you're kicking in the chats and just kind of sharing your knowledge. It's really cool. I appreciate it. Adam said page looks great. Thank you. Yeah, I'm excited about your progress too on your hundreds contribution. I think it's very exciting. It's fun to see you working on that project. And again, the wizard, I mean, a moon wizard, it sounds pretty cool. Adam has a moon wizard in his comic upcoming. Pretty cool. If you want to see previews of that, go to his channel. Check out Adam Lore's channel. Frank Salazar, you check out his channel. Frank is always working on fun stuff, including like some cool like wax seals that he's been getting into and making like 3D pieces and a lot of really interesting things. So check out what Frank is up to. Frank, thank you for stopping in and hanging out. I believe I've called out everybody who stopped by the chats. Roll for Chiraco, which I believe is Frank. Also, thank you. Okay, guys, I'm going to close it out. Have a good night. Thanks for hanging out. Thanks for talking about really interesting, fun, weird things. And thanks for being quirky. I'll see you guys on the next live stream.